What's up, AP Calculus students? Mr. Ford here with another homework tutorial. This is 4.2.4, continuing our adventure through the fundamental theorem of calculus. We are going to be doing all of the problems in this section except for 486, which we are going to skip. So let's go ahead for 483. This is a pretty straightforward assignment. So we're in kind of a really practice-y mode right now with all of this evaluating integrals stuff that we're doing. So it's going to be a really practice-y kind of day. Here we have Chang Young attempting to evaluate the integral from 1 to 5 of 5x plus 2, and here are all of his steps. He knows the definite integral, and he knows this is a definite integral, so there shouldn't be any plus c's in the answer. Also, the answer key says the answer is 68. He needs your help to find the answer and to figure out how to eliminate his plus 2c. So let's see what he did here. When he did the integration, let's see. If we were to do the antiderivative of 5x plus 2, we would need 5 over 2x squared plus 2x. I see 5 over 2x squared plus 2x plus c minus 5 over 2 times x plus 2x plus c. Oh, I see right away what happened here is that he forgot to kind of put his parentheses around this. So what he did, right here I see capital F of 5 minus capital F of 1. He took this is our capital F of function right there is the antiderivative. He took the antiderivative and he plugged in 5 and he plugged in 1. The only thing he forgot to do was to put the whole thing in parentheses and distribute, because that's where the plus c, see how it's still plus c right there? That should be minus c. It should also be a minus 2 right there, though that's the problem that you had right there. That's where he ran into it. So I think right now the correct step here would be 5 over 2 times 25 plus 10. That's correct. Plus c. In this parentheses, he should be subtracting 5 over 2 times 1 plus 2 times 1 plus c. And what will happen is that everything will kind of cancel out. The plus c's will cancel out at least. As far as this stuff goes, let's see. You'll have 125 over 2 plus 10 minus 5 over 2 minus 2. So this would be 120 over 2 plus 8. 120 over 2 is 60, so 60 plus 8 is 68. That's what happened. Just the parentheses right there. Got to remember you're doing a quantity minus a quantity, so you got to put that second quantity in parentheses. That's what happened. 484 is going to give us 6 integrals to evaluate, so let's get to work. For question A, I noticed this is an indefinite integral. There are no bounds on it, so we're just looking for the generic antiderivative. This is the new form that this will take. That's going to be, let's see, 4th power. I need to multiply 6. 4 times what is going to be 6? I need it to be 3 over 2? 3 over 2. I had to really think about that one for a minute. 3 over 2. Yep, because 4 times 3 is 12. 12 divided by 2 is 6. Minus x squared plus 5x plus c. Remember that since this is an indefinite integral, you must have a plus c on there. That's a key. Question B, I believe, is the same integral, only this time there is no, this is a definite integral. It's got 2 and 4 on it. So what we're going to do is take our answer from part A and plug in 4, plug in 2, and subtract the answers. So this might take some room here. I'm going to do B up here. So this is going to be basically f of 4 minus f of 2. So we're going to have 3 over 2 times 4 to the 4th power minus 4 squared plus 5 times 4. I am not going to put a plus c down because I am not a maniac. However, I am going to carefully arrange my things in their own parentheses. 3 over 2 times 2 to the 4th minus 2 to the 2nd power. Did I get that right? Yeah, okay. Plus 5. Oh, that should not be... Oh, yeah. No, plus 5 times 2. Okay. Just had to think about it for a minute there. Cool. All we got to do is evaluate this out. I'm honestly going to use a calculator for it because there's no need to worry about a lot of stuff here. We're just going to let the calculator do all the work. 3 over 2 times 4 to the 4th power minus 4 squared plus 20. That number. Then we're going to have, I'm just going to grab the same calculation and put a 1, a 2 in there, 2 there, a 2 there, and then 5 times 2 is just going to be 10. So that number, 388 minus 30, is going to be 358, and that is my answer for this question. Depending on where you find these questions, you couldn't see any of that work that I just did on the calculator. Oh no, calculator cam. Ah, boo. The only cool maneuver I did was I just arrowed up and grabbed this quantity and then brought it back down here and then replaced the 4 with 2. So that's the only clever thing that I did to save some time. 358. Depending on these problems, honestly, whatever you do to make things work is going to be fine. Yep. Whatever you do, if it's on the no calculator portion of your AP test, it's probably going to be pretty reasonable for you to do it with pencil paper. If it's on the calculator section, use the calculator. That's my best advice to you. Question C, very much the same. We're looking for another general antiderivative. So this one is going to be, let's see, I need to be t to the third. It'd be 3, because 3 times 3 is 9, minus t. That's it. Plus c. Don't forget about your plus c. Next, we have this guy, which is the same one, only this time we're going to be, I'm just going to kind of separate my work into sections here. We're going to be doing the same problem, only this time we got some bounds. We got -2 and we got +2. So we're going to do kind of capital F of 2 minus capital F of -2. So that is going to be, let me zoom out a little bit, will be 3 times 2 to the third minus 2. That's the first chunk. Minus 3 times -2 to the third minus -2. That's the second chunk. This one I actually am going to do by hand because I feel like this would be pretty reasonable for you to do without a calculator on your AP test. This is a good example. 2 to the third power is 8. 8 times 3 is 24. 24 minus 2 is 22. In parentheses here, this is going to be tricky. -2 to the third power is -8. -8 times 3 is -24 plus 2. I'm changing that minus negative. So this is going to be 22 minus -22, which is actually going to be 44. It's actually going to end up doubling something really quick. Okay, next question. Again, we have one more general antiderivative because of the indefinite integral right there. So this time we have this is going to be, let's see, I'm going to need a negative cosine of m. And then I need plus m to the third power. And I'm going to need 3 times what is 1/3. Wow, 3 times 1/9 is 1/3. So that's what I need there. That is a weird antiderivative plus c. And there you go. That's your general one. And then look at this. Oh, I love a trig question. Don't you? We need the capital F from that previous problem of pi minus capital F of -pi. Good news is it's sine. Sine of pi is 0. So that's an easy one. So we're going to have the sine, it's cosine, sorry. Negative cosine, which is not as nice, but still pretty nice. Negative cosine of pi plus 1/9 times pi to the third power. That is the first chunk of it. That's f of pi. Minus f of negative pi. Negative cosine of -pi plus 1/9 pi to the third power. Okay, so we got to be careful about this one. Now, here's the cool thing, is I do know that these two are actually going to cancel out, because that is the same thing. 1/9 pi to the third, 1/9 pi to the third. They're just going to cancel out. I'm going to keep them there for now to show you what's going to happen there. But as far as the negative cosine of pi is -1. And so -1 is there. This is going to be, in the first parenthesis, it's +1 plus pi to the third over 9. Minus the second parentheses. Negative pi is the same angle as positive pi on the unit circle. So this is the same thing. That is -1, so it's another 1. 1 plus pi to the third over 9. This should be 0. The answer does not say 0 if I'm looking at the answer key here. Hang on, let me think about this for a minute. Negative cosine of pi. Oh, it's -pi. I'm a ding dong. That's it. It's -pi right there. So they don't cancel out. The 1s cancel out, but the pi's don't. Now so this is going to be pi to the third over 9 plus pi to the third over 9, which you could approximate as a decimal if you wanted to on calculator cam. I don't want to. I call this 2 pi to the third over 9. whatever you want to. That's the best way to write that answer. But if you wanted to grab a calculator and you wanted to calculate really quick what 2 pi to the third power divided by 9 is, you would get that number, 6.89 or so. But honestly, College Board, AP Calc, use it, leave it as pi. Leave it as pi. Leave it alone. That's correct. Why would you go any further? Okay, anyway. Next question. Question 485, we're going to rewrite each of the following general integral expressions as single integrals. We might need some more room for these because there's not a lot of room to work with in this little space there. I might move off to the side a little bit. Question A, this is for 485. This is really just seeing if we can recognize some basic integral rule patterns. I'm going to get calculator Cam out of here because we will not need you. So really what I want you to see with this question is that these are the same integral except for the order is kind of wrong in one of them. And I think it's this one. Because usually with integrals, you always want to go from the lower number to the bigger number. So I like -5 to 3 in this g of x, but I don't like -3 to 5. So I want to think about this. Maybe I have some room to write it up here. The integral from -5 to 3, negative integral of -5 to -3 of f of x dx. There's not room in there. Right there. So we can combine those together from there. I'll write it over here. It's going to be, if I'm thinking about this correctly, it's going to be the negative integral from -5 to -3 of f of x dx plus the integral from -5 to -3 of g of x dx. Like that. And now that they're the same bounds, -5 to -3, now you can combine them together. Maybe a cool way to do this would be to write it like this. The integral from -5 to -3 of g of x minus f of x dx. I like that answer. You could do negative f of x plus g of x, but that's probably better. For question B, what we're going to do here is we're actually going to take, these already have the same bounds, so we're going to combine them together, 1 and 6, 1 and 6. Already they have the same bounds. What we're going to do is we're going to use kind of the opposite of a general general integral property because we want to combine these together into one integral. So we're going to put the 3 and the 5 back inside the integral with f of x and g of x respectively. And when we're all done, it's going to look something like this. You're going to have one integral from 1 to 6. But the f of x is going to get multiplied by 3. So it'll be 3 f of x plus 5 g of x dx, like that. Just put that number in front inside the integral. That's perfect. I like that just the way it is. Question C, question C, I'm just going to go ahead and put 0 down. Because what's going to happen here is you're going to have, you're going to change this second integral to the opposite of the integral from 6 to 11 of f of x dx. And that's actually just going to cancel out with this version right there. So this answer is 0. There's not really much more to say about it. And then question D is also pretty easy. You're just going to take the integral from 7 to 10 and subtract the integral from 7 to 9. And that's going to leave you with the integral from 9 to 10, basically like that. It's like 3 minus 2, if you think about it. It's the integral from 9 to 10. That's what's left of f of t dt. That's all I really have to say about that question. Okay. We're not doing the next one because I don't care about Hannah's version at all. Why would you do anything other than power rule at this point? Okay. Speaking of which, let's look at 487. We're going to do some derivatives. Right now, sine of x minus 5 is going to be the cosine of x minus 5. That's it. And we don't need to use any funny symbols because there's no equation here. It's just asking for what is the derivative of sine of x minus 5 is how you might read that. ddx means what's the derivative of sine x minus 5. Hey, what's the derivative of x to the 82nd power minus 6? Well, it's going to be 82 times x to the 81st, and that's it, because 6 is a constant and it goes away. Question C, a little more interesting with fractions here. You're going to have -2 times 3 over 2, m to the 1 over 2, because 3 halves minus 1 will give you 1 over 2. And now the 2's actually cancel out, and you're left with -3 m to the 1/2 power. That is the derivative. And finally, we got x plus 6 to the 3rd power. This one's going to be a little interesting here. This is going to be a little bit different. Actually, honestly, at this point, if you don't know what I'm about to do, you can skip this video because this is not going to be on your AP test. But this is testing to see if you know how to handle x plus 6 to the 3rd power. And honestly, I forget it all the time. I'm actually looking it up on a different Sum of cubes. I'm looking up on a different window browser really quick. So the sum of cubes is what's going on here. There's a formula that you probably learned at some point and you have probably forgotten. It looks like this. A to the third power plus b to the third power is equal to a plus b times a squared minus ab plus b squared. So we're actually going to expand this all the way out and then take the derivative. So this problem is not important to me in case you're frustrated. So x plus 6 times, and even then, you know, honestly, even then we got to expand it all the way out. I hate this question. I hate this. This is not on, it's not going to be on your AP test. It won't be there. And this is the kind of questions that math teachers give you to be like, haha, I know more than you. I'm smart and you're dumb and you don't know how to do 18,000 steps of work. I hate these kind of problems. Minus 36x plus 36 times 6, Jesus, 216. Like that. You know what's really nice is that these actually cancel out. X plus 6 to the third power. Oh, you know what? Oh, up. I'm wrong. Hold up. I'm way wrong. Hold up. I withdraw everything nasty I've said about anybody in this problem. X plus 6 to the third power. This is, God, Ford. You don't need that formula at all. I am especially a ding-dong on this one. What we're going to do is we have to expand this all the way out and then do the power rule of this thing. So this would be x squared plus 12x plus 36 times x plus 6. And this would be x to the third plus 12x squared plus 36x plus 6x squared plus 6 times 12, holy God. $72x plus 216. There we go. And if you combine it all together, we get x to the third plus 18x squared plus 72 plus 36 is 108x plus 216. Very cool. Now that we got that expanded out, now we're finally going to do the derivative and actually use the power rule on this. I apologize for my my language on this problem. I just don't like these kind of problems. Again, this also won't be on your AP test. It's not going to be. It's not going to be on there. 36x plus 108. That's it. There you go. So I would much rather give you the. I would much rather give you this and make sure you can do this. That's all I care about right now. Okay, moving on. Next question. 488, without a calculator, we're going to describe the graph of f of x equals that thing. A complete answer states where it's increasing, decreasing, concave up, concave down, and any points of inflection. So we're going to look at the first and second derivatives of this thing because we're actually not going to graph it. We're going to use our knowledge of the first and second derivatives to tell everything about it. So let's think about f prime of x. Our original function, if I remember correctly from this off to the side, is x to the third plus 12x squared plus 36x minus 6. So the first derivative tells us where it's increasing and where it's decreasing. Oh, hang on. Oh, shoot. This thing happened again. Oh, no. 459. Now we're way off track. I burned a lot of time on that last problem, and I'm embarrassed now. Oh, no. First derivative tells us when it's increasing and when it's decreasing. So the first thing we're going to do here is we're going to do 3x squared plus 24x plus 36. And it's going to increase whenever this is positive, and it's going to decrease whenever this is negative. So a good way to do that is to figure out when it's going to be 0. When will this equal 0? The first step in this problem would be to get rid of the 3, divide everything by 3. Make it a little simpler. 0 will be x squared plus 8x plus 12. Since we're not allowed to use a calculator, there's a good chance that this question will involve a good amount of factoring stuff, which it does. Here we can do what multiplies to 12 and adds to 8. 3 and 4? No. 2 and 6. X plus 2, x plus 6. So if I think about this graph, I'm going to make a sign chart for this, f prime of x. I know that x is 0 when x is negative 2 and when x is negative 6. So I'm going to put negative 2 and negative 6 down on this. And all you got to do really is check. I put those in the wrong order. all you gotta do is check kind of a number in between those to see if it's gonna be positive or negative on those ranges there. And you're gonna check that in f prime of x, since this is f prime of x. A good one to start with is 0. If I plug in 0, I'll get 36 out of this. That's gonna be a very positive 36. Because I know this is a parabola, and it's got parabola with a positive a term, that 3x squared, I know that the rest of this parabola is going to be, it's going to be negative in here and positive in there. You can test points if you want to. Plug in -4, for example, and see if you get a negative or positive answer. But for the most part, you're not allowed to use a calculator, so you got to kind of call on your knowledge of parabolas. This is a parabola. And it's got zeros at -6 and -2, so it's going to look kind of like that. What this tells us is that this original function, f of x, is increasing, decreasing, and then increasing again. My window's a little messed up on this today. I don't know what's going on here. There we go, it's a little better. Cool. Now let's go to f prime, or f double prime of x. That's going to tell us the concavity. It's going to be a little easier here too, because f double prime is just a linear function. It's going to be 6x plus 24. That's going to equal 0 when x is equal to -24 over 6, which is -4. So right in the middle, and that's pretty typical of these kind of problems. Right in the middle is where the concavity changes. It's really easy to test also. If you plug in like a -5 into this problem, you're going to get -30 plus 24, a negative answer. And if you plug in a positive number like 0, you'll get a positive number. So there you go. Now that's your concavity. So what that tells you, if you look at this now, is that there's also a break at -4. This graph is concave down before -4, and it's concave up after -4. So if you break it all down, there's kind of 4 sections to this graph. If x is less than -6, it's increasing and concave down. If it's between -6 and -4, it's increasing and concave up. Sorry, concave down. Sorry, whoops. Decreasing and concave down. In between -4 and -2, it's decreasing and concave up. And after -2, it's increasing and concave up. That's that. It tells you the shape of the graph here before you do anything. And all we got that was from first and second derivatives. Really important skill. I said this is going to be an easy video, and it's already over 22 minutes long. I don't intend it to be that long. I think I'm doing a little more explaining than I used to do in these videos. 489, we're going to write the equation of a line tangent to a graph at that point of inflection. The good news is it's the same function as before, so these two problems kind of go together. Oh, we're also asked for at a point of inflection. Well, that's going to happen at -4. That's your point of inflection, because that's where the second derivative equals 0. So for this next question, which is 489, we are investigating what's happening at x equals -4. We're going to need to know what f of -4 is and f prime of -4 is to write the equation of this line. The original function value at -4. I'm going to use a calculator now because it says I'm allowed to. I'm going to bring calculator cam up here so you can see what I'm doing. All I'm going to do here is just plug in -4 into the original function. -4 to the third power plus 12 times -4 squared plus 36 times -4 minus 6. It's going to be -22. That's going to be kind of like the y value in our point slope form. As far as f prime, that's going to be the slope. F prime is going to be 3 times -4 squared plus 24 times -3 plus 36, which is going to be 12. That's going to be the slope of this line. And now that we know all this information, we can really easily write the equation of the line. It's going to be y plus 22 equals 12 times x plus 4. Again, I'm just adapting that from the regular old point slope form. Y minus y1 equals the slope times x minus x1. Except for here in AP Calc, it kind of has a new flavor. Y minus f of a equals f prime of a times x minus a. These are all three of them the same. There's the calc version, the original version, and the version specific to this problem right there. That'll maybe help you out a little bit with this. You're going to keep seeing a problem like that on pretty much every homework set from now until the end of the class. So 490, one more of these. Earlier in the chapter, it was discovered that f of x equals the cube root of x is not differentiable at x equals 0, which it is not. Why does it not exist? Well, let's just try to find the derivative. Of the original function, f of x is equal to x to the 1/3 power. F prime of x then would be 1/3 times x to the negative 2/3 power. And if we rewrite that, it's going to be 1 over 3 times the cube root of x squared. And here's the problem. If you try to do f prime of 0, you end up getting a 0 on the bottom of the fraction, and so it's undefined. F prime of 0 is undefined. That's why it's not differentiable there. You can't get it. So question B and C are going to ask us about a couple other functions. Both of these are very similar. So B is g of x, which is the cube root of x squared, differentiable at x equals 0. So let's take a look at that really quick. I'm going to do this off to the side. G of x, I'm going to write that as x to the 2/3 power. Its derivative, g prime of x, would be 2/3 times x to the negative 1/3 power, which would be 2 over 3 times the cube root of x. I believe this is also not differentiable at x equals 0. And I'm going to point to the same reason. It's also going to be undefined. It's because x on the bottom of the fraction, if you plug in 0, you're going to get undefined, and that's not going to work. Question C, h of x is an even easier function to deal with. H of x is equal to the cube root of x to the 3rd, which you smart people out there are just going to recognize as just x. That's the same function. And h prime of x is equal to 1, and so it totally is differentiable. It's differentiable everywhere. There is no problems with h of x at all. No issues. The question here is explain why there's a point of inflection at x equals 0 for f of x equals x to the 3rd power. So now we're back to f of x over here. Let me zoom in on a little bit. Let's take a look at the next level down. What's f double prime of x in this case? I'm going to use this top version up there to make things a little easier there. This would be a little easier to work with. Negative 2/3 times 1/3 would give us negative 2 over 9. And x to the negative 5/3 power is going to be where we're going to take that degree to. So again, if I rewrite this, it would be, let's see, it would be negative 2 on top. We'd have 9 times the cube root of x to the 5th power. It's not so much that it's differentiable there, but there is going to be a point of inflection because critical points or points of inflection can happen either when the function equals 0 or when it's undefined. If you look at what's happening here, it's not so much that you actually can take the derivative there, but at 0, you might say that at x equals 0, f double prime of x changes sign. If you were to plug in a negative number, you'd get a negative answer. If you were to plug in a positive number, you'd get a positive answer. Or I think it's the other way around because of the negative 2 on top. Doesn't matter. It's going to change sign, and that's going to create a point of inflection, regardless of whether the derivative actually exists or not. So that's what's happening there. Let's try one more question. 491, pretty easy actually. A little easy one to land on. 491a is the easiest question in the world. The integral from 2 to 2 of g of x plus 3 absolutely does not matter what's going on there. This is going to be 0 every time. Now, as far as the next question goes, the integral from 4 to 2 of 3 minus the g of x dx. What we're going to do is a significant amount of work with this thing. The first thing we're going to do is we're going to change the order because 2 and 4 are kind of backwards right now. So let's go we'll make it the negative integral from 2 to 4 of 3 minus 5 times g of x dx. What we're going to do now is separate this into two integrals. This will be the negative integral. I'm going to actually do this whole thing in parentheses and apply the negative at the end. The integral from 2 to 4 of just 3 dx, which we can do by kind of thinking about it as a rectangle, minus 5 times the integral from 2 to 4 of g of x dx. there. Now, what's nice is that we actually already know that the integral from 2 to 4, oops, highlighter please, is equal to 6. So that whole chunk there is just going to be the number 6. So we're going to have a negative, let's see, integral from 2 to 4 of 3. That's going to be just a rectangle that is 2 wide and 3 tall. So that'll be 6. I guess I'll say 2 times 3, like that. Minus 5 times 6, which is what we know that yellow integral is. So this will be negative 6 minus 30, which will be negative 24, which is going to be positive 24. And that is the answer to that question. Whew. I did not think this would take over 30 minutes when I started it, but hey, there were some pretty rough questions in there. Also, I ran into a big headache on one of the problems there, so keep it up. You guys are awesome doing this stuff, and I really appreciate you being here and being with me the whole time, so that's great. Keep it up. You're awesome. I'll see you in the next video.